So welcome to the ICID webinar on innovative coastal protection on mangrove coasts. This is a very important and very relevant webinar, especially when we are fighting with the climate change and the related issues of coastal erosion, as well as the disasters like tsunami, etc. So we are starting this webinar with the help of the working group chair, Mr. Dr. Kao, and the moderator will be Dato Engineer Noor Hisham bin Mohammed Ghazli. He is also Vice President of ICID. And then there will be 3 speakers who will also be moderated and introduced by the moderator. Next. So next. Yeah. And after the presentations are over, you can type your views or your questions in the chat box, and the presenters will be able to answer them depending upon the availability of the time and various other informations. So we are indeed happy that the coastal protection is being taken up, which is a very vital aspect of the water management, and this is an area which is not really understood very much in the rest of the water resources community. So the mangrove forests, which have experienced a lot of degradation, as well as various other attacks from the developmental projects and various other climatic effects, are in strong need of protection. And for that, the seminar will go a long way in providing the information and the latest technologies. So now I welcome once again the chair of the working group and the moderator, and I will hand over to the chair of the working group for few opening remarks, after which he may hand over to the moderator, Dr. Ghazali, for further proceedings. Thank you.
Yeah.
Dr. Kao, you can continue. You can start speaking.
Okay. Thanks, Secretary General. Welcome you to join us. And first of all, I would like to express my thanks, very deep thanks, of the moderator of today's webinar, the Vice Chair of STTA Working Group, and the Vice President of ICID, Dr. Noor Hisham. Thanks again for his carefully planning and arrangement of this working group's first webinar, and invited the 3 very professional and distinguished speakers in coastal conservation, gave us a wonderful speech. And we also thank Mr. Pavian and Reddy, secretary of the working group, and the Chivet, the technical director of ICID Central Office, for their contribution during the preparation periods. I would like to welcome all the members who joined the webinar today. And then I think I will invite Dr. Noor Hisham to host the webinar for us. Dr. Noor Hisham, please.
Thank you very much, Professor Kao. Good evening, Mr. Secretary General, Mr. Shivas, and friends at ICID Central Office. Also on board are members of the working group for SDTA. And it's my pleasure to introduce and welcome speakers and participants to this webinar on innovative coastal protection on mangrove coast. And allow me to give some simple introduction. We decided on this topic because the challenges that face mangrove coast is probably more severe than other coastlines, particularly because mangrove coasts are by nature very flat, and that exposes it to even the slightest increase in sea level rise. And sea level rise is bound to happen because of global warming. And we have also seen over the years an increased frequency of storm surges along our coastlines. So Malaysia's coastlines of about 8,000 kilometers in length is facing severe threat. About of that size, from that amount, it's about 1/6 of that length is facing erosion. So Malaysia's mangrove forests have experienced much degradation over the last 2 decades, and incidents of wave overtopping and erosion has been occurring more frequently. In Malaysia, the mangrove forest distribution is estimated at 0.58 million hectares, with some of the forests being gazetted as permanent reserve forests. In an effort to conserve and protect the forest for future generations, we have gazetted this forest, and we have also installed protection, engineering intervention of these our coastal embankments that protect these lands adjacent to the mangrove coasts. Nevertheless, there has been a rise in coastal embankment damage incidents due to storm waves and high tides. While we have implemented structural solutions over the years, after the 2004 tsunami, the Malaysian government introduced a nationwide mangrove replanting program. But it has faced a lot of challenges due to the high mortality of saplings that we plant. There's a lot of challenges due to the forces and due to the conditions on the shoreline that makes it difficult for us to plant, even to replant degraded mangrove forests. This webinar is intended to share some of the efforts that we have carried out in Malaysia with regards to protecting mangrove shorelines. And you will find that the challenges are pretty much similar in other parts of the world where you have similar types of coastlines. So without further ado, let me introduce the first speaker today. She is Nor Aslinda Awang from the National Water Research Institute of Malaysia. Engineer Nor Aslinda is currently the Director of Hydraulic Laboratory and Instrumentation at NARIM, National Hydraulic Research Institute. It was called the National Hydraulics Research, but we recently changed it to National Water Research. She first joined NARIM as a research officer in the year 2000 and served in the Coastal Management and Oceanography Research Center. She has a Bachelor's of Engineering in Civil Engineering from Mara University of Technology and a master's degree in Earth Sciences, specializing in mangrove hydrodynamic modeling from the University of Waikato in New Zealand. She is a member of the International Association of Hydro Environment and Engineering Research and part of the Malaysian Mangrove Alliance Discourse Group in Malaysia, an Ocean Malaysian partnership team. She has over 20 years of experience in various R&D projects concerning coastal hydraulics and numerical modeling for coastal mangrove replanting. She has been recently involved in research on climate change and sea level rise impacts on the coastal area and physical modeling on the impact of coastal protection structures, coastal estuarine and coastal morphology. Until 2019, she was actively involved in the National Committee for Mangrove Replanting along the Malaysian coast and the National Committee on Coral Triangle Initiative Program for Climate Change Adaptation. Without further ado, I'd like to invite Aslinda to give her first present her presentation. You have 15 minutes, Aslinda. Please share your screen.
Sorry.
Yeah, you can
Thank
see.
you.
Yeah.
I don't know how.
Can you see share screen at the bottom of your screen?
Yeah. Okay.
All right, there you go.
Okay. A very good afternoon to Dr. Kao, the chairman of ICID committee, Dr. Engineer Noisham, aka Mr. Moderator, ladies and gentlemen. Thank you for allowing me to participate in this webinar. The title of my paper is Mangrove Diversity, Importance, Threat and Conservation Efforts in Malaysia. So as an introduction, coastline of Malaysia, we have, according to NCES 1985, we have about 4,800 kilometers, which consists of sandy and muddy coast. In sandy area, it is vegetated by casuarina, coconut, and other coastal species, while muddy coast is vegetated by mangrove forest, and mostly muddy coast is mostly located in the west coast of Peninsular Malaysia and patches in Sabah and Sarawak. This map is not in scale. It's not scale. It's a schematic plan. Okay. Mangrove forest is salt tolerant tropical shrub and trees growing in river, estuaries, and intertidal zone, also referred as forests between land and sea. They can be found in tropical and subtropical region and most abundant in tropical Asia, Africa, and island in Southwest Pacific. They are rich in biodiversity, key contributor to coastal economic and important source of livelihood. The figures show the mangrove vegetation zone with where different species of mangrove that grow normally, and the most common is Rhizophora, Avicennia, and Bruguiera. And the importance of mangrove, they protect coastal land against destruction of ocean waves, tsunami, and storms. They are natural fortress for coastal stability because their roots and trunks can act as sediment trap and help in soil formation. They also function as natural filter to improve marine water quality. They play a unique role in ecology and biology, such as supply of timber and water storage, and prepare nurseries and habitat for fisheries, prawn, and many species. And they also promote ecotourism. Another important is they are significant carbon sink in coastal environment, which they can store the highest biomass carbon compared to other forest types in the world, around the world. So in monetary value, mangrove forest conservation could provide a profit of USD 300,000 per kilometer. And another study found that mangrove forest can provide ecosystem services valued at USD 200,000 to 900,000 per hectare, depending on location. Socioeconomic study in Salabat Mudflat Nature Reserve Sarawak estimated income from fisheries about 56,000, more than 56,000 USD per month. And the area, 199 hectares of mangrove forest there can generate approximately 3,400 USD per hectare. Another study on economic evaluation at Kuala Perlis Forest Reserve in Peninsular Malaysia, the estimated income is approximately 75,800 USD per hectare, and the estimated total value of the forest is about 3.2 million for 42 hectares USD. Sorry. Okay, global distribution. In 2010, Spalding et al. Found study that the total coverage of mangrove worldwide is about 15.2 million hectares, and 5.1 million hectares is located in Southeast Asia. Malaysian mangrove forest is the 6th largest in the world after Indonesia, Brazil, Australia, and Mexico, and Nigeria. It's about 0.58 million hectares. So the latest study in 2017, Hamdan from Forestry Research Institute of Malaysia, using satellite remote sensing, and he found that we have now 6,029,000 hectares. 629,000 hectares, where 18% is in Peninsular Malaysia, and Sarawak is about 22%, and another 60% is in Sabah. So threats and challenges. The global mangrove has experienced net loss in as a result of human activities and nature. So according to FAO, Food and Agriculture Organization of United Nations, the global area mangrove had decreased by 0.5 million hectares from 1990 to 2010. So the human activities are such as land conversion, over-harvesting, pollution, and sedimentation. And in Malaysia, land conversion is the main threat. Another the natural processes are such as coastal erosion and rising sea level. So the coastal erosion in Malaysia, in 2015, National Coastal Erosion Study was revised, and the total length now is about 8,840 kilometers, because they include the islands now, about 40 islands around Malaysia. So the erosion rate was categorized by 3, 1 to 3, which is critical or high, with erosion rate of more than 4 meters per year. Category 2 is significant, with erosion rate of 1 to 3.9 meters per year, and category 3 is acceptable. Its erosion rate is less than 1 meter per year. So the table show the differences between the 1985 and 2015. In category 1, most of the probably the reduction in category 1 is probably because most of the critical area previously has been protected by structures, and category 2 increase because the acceptable area previously has been disturbed by development, and the category 3 is reduced probably because the stable area previously has also been disturbed. So, example of erosion in mangrove area, in the southernmost tip of Asian continents, where we have Tanjung Piai, they have a lot of mangrove, but now have already degraded because of erosion. It was reported that the rate of erosion range from 3.2 to 12.5 meter per year. So the lines show that shoreline changes from 1990 to 2000 and 2017. So the photos shows a lot of mangrove have been dead. So we lost some area there. So the second, another area is in Kilim Geoforest Park, Langkawi. This area is a tourist area with many visitors, and the authority did not impose the speed limit for the boats, even though there is signboard asking to slow down the boat speed. because of the many tourists, the boat tends to speed up so that they can have more trips to bring in the tourists. So these are what happened to the mangrove, the existing mangrove. So another threat is from sea level rise. So in Malaysia, we have study a projection of sea level rise along the coastline, along Malaysian coastline. So in 2017, the projection of sea level rise is that along Malaysia coast is between 0.67 to 0.74 at year 21,000 compared to the global projection between 0.73, 0.52 to 0.98 meter. So sea level, climate change caused sea level to rise and more storm surge. So the physical impact is flooding, saltwater intrusion, erosion, and also changing of coastal ecosystem. On the socio-economic impact, the sea level rise can damage the coastal infrastructure, loss of land, loss of coastal ecosystem, and reduction or loss of income. So photos show some of the incidents that occur in some areas in Malaysia, overtopping and inundation and erosion in Terengganu. So we also studied the inundation area in Port Kelang to see the impact of sea level rise in mangrove area. So sea level rise causes changes in inundation duration, level, frequency, velocity, wave height, type of sediment, and salinity level, which may lead to plant death. So in the first sea level rise of 0.5 meter can affect about 14 kilometers square of mangrove, while sea level rise of 1 meter of the existing level will affect about 37.5 kilometers square. And if we take the maximum value of sea level rise of 2.2 meter, the total affected will be 116 kilometers square. So this shows that mangrove will decrease area, mangrove area will decrease in the future. So in the effort of mangrove conservation, after the tsunami 2004 had increased recognition of the importance of conserving and restoring mangrove as natural protection to shoreline. So in 2005, Malaysian government allocated about 9 million USD funding for planting of mangrove and other coastal species along coastline with 1.8 million USD for R&D. Other coastal species are, because the sandy coast, we also have to protect them. So we plant casuarina more and other species that is suitable in that particular area. So mangrove planting need knowledge and skills. Not all planting project is successful. So we need information on soil condition, monsoon season, and hydrodynamic parameters, crucial before planting takes place. The best planting time is after the monsoon in area with low and wave low wave and current impact. So Dr. Lee will speak more on the R&D which we have carried out for mangrove conservation later. So other than R&D, we also built more nursery to enhance the seedling productivity, and in some area, in some problematic area, we have we did mangrove replanting using innovative technique such as COMMAT and COMPILO.
Cinda, I will allow you 2 minutes more to conclude.
Okay, just 2 slides more. Okay, community involvement in mangrove restoration, rehabilitation and planting effort is also crucial in conservation of mangrove. So we involve the school, children, private companies, government officers, and also villagers to participate in this planting program. And the NGOs have their task in the effort to conserving the mangrove. They help these awareness programs such as like Malaysia Nature Society. They show the children how to do the nursery, and Global Environmental Center in planting the mangrove, and rural citizen in Kedah did a lot of awareness for school children. Wetland International create nurseries for seedling, and also World Wildlife Fund in Terengganu, they have a lot of programs to encourage school children in replanting of mangrove. This PIFWA is Penang Fisheries Welfare Association. They have contacts from private entities and also foreign visitors who have interest in preserving mangrove, and they invite all foreigners to come and help them to plant the mangrove. So with that, thank you. Dr. Lee will continue with the second session of this.
All right, thank you very much, Linda. So if I can just get back to our hosts, do we want to have Q&A now, or shall we keep the Q&A till the end of all the speakers after they've presented?
No, we can have QA at the end of the session so that both the presenters get adequate time to present their
okay, very good. Very good, thank you. So keep your questions coming in. I can see some questions already coming in from our participants. So I will go through them when we get to the Q&A session. Okay, in the interest of time, we move on to the next speaker. And she is Dr. Lee Hin Lee, and she is currently Director of Coastal and Oceanography Research Center at the National Water Research Institute of Malaysia. And she began a career in government as a civil engineer in the Department of Irrigation and Drainage. And she has a bachelor's degree from Hanyang University in South Korea and a master's and PhD from National University of Malaysia. And she is skilled in physical and biological analysis of river waters, lakes, estuaries, and nearshore waters. And she has a wide experience in the use of numerical modeling and geospatial analysis tools in analyzing and predicting spatial and temporal morphological changes on a basin scale in nearshore areas. Dr. Lee, without further ado, can you please take the virtual floor?
Yeah, thank you, Dr. Hisham. Good afternoon to everybody. Actually, I'm going to talk more on the R&D regarding the mangrove innovations. So this point is we look from the Nahrim itself. How is it Nahrim carry out this R&D for the mangrove? Next, please. Is it Aslinda is controlling the thing or how is it? Okay. When we want, because I know that this is from the ICID, but ICID is more talking about the drainage and irrigation system itself. So when we talk about mangrove itself, it means that mangrove will grow between the terrestrial and the near shore. Because of that, we know that mangrove can be a buffer that protect the paddy area at the back there. This mangrove can absorb the energy and reduce the overtopping of the wave of salt water into the irrigation system. And also this mangrove can protect the drainage or irrigation system from the eroding because of the current from the near shore area. So the main thing is this mangrove can protect the irrigations and drainage system and the paddy area at the terrestrial land next to the shoreline. Next, please. Okay. Okay. Actually, Nahrim have carried out a series of study that has been displayed here. This is all the areas that consist of the mangrove that from our previous about 10 years study from on the mangrove. So we have a finding on how is it if let's say we want to handle and we want to plant the mangrove itself. Next, please. Okay, okay. In general, we have carried out the R&D research, and also we carry out some consultancy job. So from this, all the R&D and the consultant research, actually there is few things that when we talk about to plant the mangrove. So mangrove, they want, at least if we want to do the mangrove or we want to make sure that mangrove can be sustained in the good conditions, actually mangrove like to be in the conditions that their current speed is less than 0.3 meter per second. It means that if my current speed is lesser than this 0.3, then they can grow very well. But beside this current, actually, they also be affected by the wave. If the wave height is more than 1 meters, it means that this wave height will be causing some forces, and this one will bring the erosion away from the mangrove. So the second condition is the wave height must be less than 1 meters. And in general, we can say is that the calm area at the particular site that when we have a mangrove, we want to make sure it can be sustained for a longer time. The calm area must be calm area in terms of the from the wave itself must be calm about 50% calm conditions. And also this when we talk about mangrove, they need to have a lot of suspended sediment. It means that 150 milligram per liter. If we have more than 150 milligram per liter of suspended sediment, then they can become better. And another one is they must be not in the conditions of the erosion beaches. Okay, next please. So it proved that through our series of site visit that we can find actually when we talk about mangrove, they have 0.3 meter. You can see that mangrove grow very well, where they have a very high current. Even though after we do the replanting, hardly we can see any mangrove can survive in that area. This one is plus together with the higher wave conditions at the particular site. Next, please. Next, Selina. Next. Okay. Okay. I would like to show. Selina, maybe you can go off and let me control the. I think control the slide. I think I feel more. I prefer to control the slide by myself. I think. Can you go out from this one, Aslinda? Can you stop your slide? Then let me, I share my own slide. Okay. Boleh Datuk Isham nampak tak Datuk?
Yeah, can see. Just proceed.
Okay, now, yeah.
Can you go to full screen?
On the full screen.
Down at the bottom, you can find it.
Yeah. Where is it? Full screen? Where is it?
It's down in the bottom right corner. You can find small icon near the slide bar. See the negative and the positive bar is next to that. Can you see?
You can also get it on top of the screen
Yes, you can go
on
to
the
the
left
top
side. On the left side.
on the view.
You can go to slideshow.
Go to slideshow.
I stop again.
So you're okay. Just go to slideshow.
All right. Okay. I cannot go to the slideshow. I don't know why. Okay.
Slideshow.
Yeah. Okay. Is it all right?
Yeah.
Okay. All right. Okay. All right. So now I would like to show the case study. Actually, how is it so important before we do the planting? We have to know few things because series of analysis and carry out that when we are not study the proper hydrodynamic at the planting site, then we lost a lot of money on that. So, for example, there is a study at the like what mentioned by Aslinda. Most of the street marker they have sandy, they have a muddy beach, so it's very nearby to this we call it Sungai Perak area. So we have carried the wave analysis and we found out actually. If we look at here, the red color, it means that those in the brown color, your wave is less than 1 meter, whereas the one that in the light brown, it will be more than 1 meter. So from here, if we compare two sides, one is side 1 and side 2. This result is from the numerical model. What we found actually, the side 2, they comply that the conditions just now we mentioned about hydrodynamic conditions. Their condition, they have a 1 meter less okay in that condition. It means that should be complying with the condition that when we talk about want to have a mangrove. So, so the second conditions that we request under replanting exercise. Actually, this area they're having erosions happen. So the second condition is the wave must be less than 0.3 meter per second. If we look at this side 1 and side 2, what we found actually, side 1, the current speed is more than 0.3 meter per second. Whereas the side 2, their current speed is less than 0.3 meter per second. It means that again, side 2 is complying with the condition that just now we mentioned about hydrodynamic. So, so if in general we see the side 1 and side 2, these two conditions, what we found, the one that side 1, because they are not comply with the conditions that just now we mentioned, all the planting, the exercise planting or replanting exercise, all the mangrove seedling all gone because they have a higher current speed and they will have a higher wave height. Then all this area, no mangrove can survive under this area. This area actually is very nearby to the northern side of Sri Malacca. That they're planting this mangrove because of to protect the shoreline from the tsunami in the future. In the future. So, but the one that in the side 2, what we've been planted is they grow out very well. So about 95% the mangroves growing. So this is very important when we want to do the planting. It doesn't mean that we want to plant the area. We look at that the area is a muddy coast. There is a muddy conditions. Look at the area is very calm. We do know that because the condition changes year long time, because we are being controlled by the tidal, we are controlled by the wind and all the things. So the hydrodynamic condition is very important, that at least we know that the money we use won't be wasted like that, because the mangrove will go away if we don't have a proper understanding of hydrodynamic at the site. So same thing when we talk about sea level rise in these global warming times. Well, what we know that mangrove can grow well in the condition from the mean sea level until the mean high water spring. So if we look at this area, it means that they are all, because different salty concentration, they have different kind of mangrove. So when they go more further inland, they are going to have the one that lesser salt. So under this condition, nowadays we have a very biggest range of the mangrove, because our mean sea level, and the mean high water spring is there that to allow the mangroves to be grow up in that condition. But when we talk about sea is rising, it means that my mean sea level must plus certain height. Let's say it's about 1 meter. It means that now the mean sea level, we are going to have higher height. It means that we are going to have higher height. Same thing to mean high water spring also, we are going to have higher height, higher level. So what we can see here, those areas, it means that my mangrove now will be shortened, because this area, the blue color block here, because we have about 100% be inundated by the salt water. So we don't have any mangrove in this area. It means that this area, until this blue box of this what being mentioned here, these all mangrove were gone. We just left with this mangrove only, the one that in the yellow box area here. So as person who want to protect the hinterland or our terrestrial area at the site, so we have to protect this mangrove. How to protect this mangrove? So we need to have another structures to let the we have to make sure that this area, the soil must be increased, so our main sea won't be so high there. There is another technique that's supposed to be applied in the R&D. Okay. So what we can say as a sub-key finding here is actually mangrove play the vital role in the protecting the drainage and irrigation system from erosions and wave overtopping. So it's very crucial, because sometimes when we talk about paddy planting, normally they are in the very low area and very near to the shoreline area. So this mangrove can help the farmers to reduce their problem because of the wave overtopping and erosions. But anyhow, mangrove can grow well in these conditions. So if the mangrove cannot, if let's say the site cannot unable to provide or fulfill this condition, so we need to have some support. This salt or hard protection is needed to reduce the energy that to get the mangrove to grow well. So we will see how is it Malaysia carry out this study. Actually, Nahrim is the one by knowing that our shoreline, especially in the Strait of Malacca, being attacked by the tsunami in the year of 2014. So planting mangroves is one of the important things for us. So that mangrove Nahrim will be carried out to undertake the numerical model hydrodynamic to do the analysis, and we provide to assist this forestry department before they carry out the replanting. To carry out the numerical model, actually series of jobs to be carried out. One is we have to go for data collections, data processing, modeling, calibration, hydrodynamic, and only we can come up with a finding on what happened, hydrodynamic conditions in within 1 or 2 years time. How is it the hydrodynamic condition at the site? So this is the equipment we use at the site that we deploy the wave to measure the current speed. Then we put in some, this is also wave measurement also, to put a tied to the mangrove to see how much is it the current speed at this one. So we need to use this current speed result to calibrate our model to come up in the future to project when there is a northeast monsoon, southwest monsoon, inter monsoon, with the wave, without the wave, all this exercise supposed to carry out before we can advise the forestry department how is it they have to apply the protections. So this is some of the result. This is hydrodynamic result to help the planting mangrove planting committees to carry out their job. So this is one example also at the also very nearby to the just now the site at the Strait of Malacca. So actually Nahrin carry out the hydrodynamic study on the housing we want to put in the geotube, because geotube they are big but easy, then we can put at the a little bit at the offshore a little bit. So to carry out to analyze how high is it they supposed to carry out this geotube at the site. So actually DID will carry out the installations of the geotube. Then when we have this geotube, then this one the forestry department for a research institute of forestry start to plant the mangrove. It's the first few months. This is the conditions. After that, because when we have the geotube here, we are providing the calm area at the back of the geotube, so they can start to do the planting. Then we can see that the mangrove is planting now, is growing out until move to the near shore area. Another thing is we are using the structures like constructions of the revetment. This is the revetment to reduce the energy, to break the energy because of the mangrove itself. Because mangrove itself, it doesn't mean that with the mangrove the shoreline won't be stable. No, because mangroves also depend on hydrodynamic. If we have a higher hydrodynamic, it means that they will die off. So to protect them, actually we need some little bit of structures, but not high, like revetments that can protect this mangrove from more degraded from the shorelines, or any structures like this one. But anyhow, when we talk about structures that we are built like this kind of structures, it doesn't mean that we want to put the structures just like that. Actually, we have to study the hydrodynamic. Where is it the dominant wave coming? Where is it the dominant current directions? With that only we can decide the orientations of the structures itself. So this is also have to use numerical model to detect how is it orientations of the structures that to reduce the wave energies, incoming wave energies. Or another structures like the escarpment that we along the shoreline, that we have provide some channels in between the escarpment that to let the salt water to go inside the mangrove to let the mangrove survive. Okay, there is few other structures that we can apply when doing this one, but okay. Or another type of structures. This one also geotube. You can see that is an erosion beach. Then after GPS putting in the geotube, the beaches or the shoreline become increased because of they reduce the erosion happens. So nowadays they have like built with nature. They are using the mangrove stick to put along the shoreline. Also, there is another method that to reduce the energy go to the replanting area to let the water to have a more calm area at the back of the those structures, so we can do the replanting. So with that, the finding is this mangroves is very important because they are protect the drainage and irrigation system. Mangroves can grow well with a certain hydrodynamic conditions, but appropriate adaptations are needed, hard or natural-based solutions to protect the degraded mangrove. So research R&D activities, especially we have to understand the hydrodynamic condition is needed before we undertake any mangrove restorations. So at least we can reduce the losses that we are going to face in the future. With that, thank you very much.
Thank you very much, Dr. Lee, on your detailed presentation on the efforts that we have undertaken in Malaysia on restoring the mangrove forest and our attempts at trying to replant mangroves on open coast. So the need to understand hydrodynamics and the interaction between structures and waves and currents are important to reduce the energy before it hits the mangrove belt line. So this has been a great challenge for us, and that was the key elements of Dr. Lee's presentation. So keep sending in your questions. We will move swiftly to our third and final presenter for today, Engineer Arman Mokhtar from the Department of Irrigation and Drainage Malaysia. A quick introduction. Engineer Arman joined the DID in 2001 and is presently the Deputy Director and subject matter expert on coastal zone in the Coastal Zone Management Division. He graduated from the National University of Malaysia with a bachelor's degree in civil engineering and obtained his master's from UNESCO IHE in Delft, the Netherlands. And he's a professional engineer and an Asian chartered professional engineer and has over 20 years of experience in coastal hydraulic engineering, dredging and reclamation works, and including coastal numerical modeling and design of coastal structures. He's now actively working on innovative coastal engineering designs for various agencies in Malaysia. Arman's presentation is going to be slightly different than the first two. It focuses more on the engineering aspect of constructing coastal structures. Over to you, Engineer Arman.
Thank you very much, Dato'. Can you hear me, Dato'?
Yes, we can hear you.
Okay, thank you.
Share your screen.
All right. Okay, Tok, shall I start?
Yes, please, carry on.
A very good evening or very good afternoon, everyone. My name is Arman Mokhtar. I'm from Coastal Management Division, Department of Irrigation and Drainage, Malaysia. Today, I would like to share with you all a presentation. Title. So there's a problem is in the connection. Can you still hear me, Dato'?
Yeah, we
Yes,
can
yes.
see your presentation.
Yeah, carry on. We can see the first slide.
Okay. A presentation entitled Eco-Friendly Rough Pile Foundation System as an Alternative Piling for Soft Ground Area in Malaysia. Okay. Well, let me introduce on the piling system normally used in soft ground area in Malaysia. Basically, we have two types of foundation. The first one is we call it end-bearing pile, and the second one is friction pile. And we know that the foundation system is basically we are transferring the loads to a deeper and competent soil. So if you have a load, we normally transfer the load to the competent soil, and the problem is with the soft soil in Malaysia, we have a very thick marine clay or peat, and friction pile is basically synonym to piling in soft ground area. Of course, we all know about concrete piles. Concrete piles is very strong and durable, and basically quality is assured because it's actually made in the factory. But this disadvantage of using the concrete pile, especially in the soft ground area, is basically, of course, it's quite expensive, and it's heavy and requires special machinery for installation. So bringing heavy loads and special machinery to sites is quite a challenge to us normally in doing construction works in the soft ground area. And of course, it's quite difficult to handle in soft ground area, these heavy things. And if you look at the alternative, the other alternative is, we call it bakau piles. It's actually a wooden pile. It's actually harvested from the mangrove trunk. So we normally call it, the local names for it is called bakau piles. And the advantage of these wooden piles basically is so much cheaper than concrete piles. And the most interesting thing is actually quite durable. if it is submerged in underwater. So, you know, people will say it's quite, this pile is quite durable and is very cheap as well. So this disadvantage of these bakau piles or wooden piles, basically now is we have a problem with supply issues. And, in Malaysia, we have lesser and lesser area of this, to harvest this mangrove. And normally we import it from other country as well. So, and it's also subject to quality because of the specification. Those days is just basically we need to have like 4 inches of girth, and nowadays it's very hard to find that kind of size and the hardness, and because of is prematurely harvested. And of course, to coastal engineer like us, it creates a lot of environmental problems and also coastal erosion issues. This is a typical view of mangrove forest, a good mangrove forest in Malaysia. You can see that the root system is basically plays a very important role in absorbing the wave and also harbors a lot of ecosystem in the area. And we can see that the importance of the mangrove forest for us is basically, of course, I don't want to talk about a lot about this the environmental things, but for us it's very important to protect our shoreline against the wave action, and also it traps sediment to build a new land. So this is actually to prevent against coastal erosion to our coastline. And if you look at this picture, basically we have a very thin, in most area we have a very thin layer of mangrove protecting our coastal bands or dikes behind it. And you see here is a paddy field, and it's protected by a coastal band, and that coastal band is protected by a mangrove, a thin layer of mangrove. And it's actually very critical for us, because if we lose this mangrove area, basically we need to do another type of protection to protect our coastal bands. And also the problem, like what I said just now, is mangrove also is used as piles in local construction industry. So in a way, this area also is subjected to, people would like to use this as a cheaper alternative of piling as well. So this is how it looks, the wooden piles or bakau piles. How it looks is actually used for light foundation works in the construction. And the issue is basically the first issue is basically we use this a lot in the those days. We use this bakau in our construction industry. And the other issue is basically we now actually facing a lot of mangrove deforestation for aquaculture and agricultural land. So these two issues basically create pressure to our mangrove ecosystem, and leads to degradation of the mangrove itself, and also later will contribute to coastal erosion problems. For your information, the government has spent millions, 100 millions of ringgit to prevent or to protect our coastline against coastal erosion. And if you look at the impacts of using the wooden piles or bakau piles, this is some of the values that we calculated, and I just summarize it. If you want to have 0.05 hectares of foundation area, we need to harvest mangrove area of 1.4 hectare, which is actually 28 times more. Talking about the 28 times the area of the foundation area itself. So if we don't have mangrove, then basically what we need to have is to have a this kind of protection. We call it rock revetments. And this is a typical rock revetment protecting our coastal bands when we don't have bakau anymore. And the problem is with building in very soft ground area, it's also subjected to inadequate bearing capacity problems and consolidation settlement. From this picture, you can see that there is failures in the rock revetment itself when we build it on the soft ground. And normally because of heavy machineries and also because of the soft ground conditions. And bigger embankments normally require better foundation. And that's where we come with the alternative pilings. We call it the ERP system, or eco-friendly rough pile system. So the eco-friendly rough pile system is basically a trade name of innovative system designed to provide an alternative to bakau piles in soft ground areas. Basically, this is actually our effort to reduce the pressure to the bakau piles or back to the mangrove areas. And it consists of two elements, the rough and the pile element. And it is designed as an integrated grid series to improve soil bearing capacity and also will increase the lifespan of our structures. So this is how it looks on the ground, and we have that piles underneath the rough. Let me show some videos. I think 2-minute videos of the ERP. Okay, Datuk. I think my last part of the last part of my presentation will be this one, Datuk. Basically, you know, we engineers like to compare things, and we normally use this value curve for foundation alternative. We normally look at it as from different perspective, normally resistant to load. Of course, we need something that can resist the load. Availability of material, easy handling and installation, environmental friendly, and of course, cheap or cost. Yeah, and of course, this is actually the if we put it in a graphical form, basically this is actually the value curve that the ideal value curve for foundation in soft ground areas. And if we compare some of the alternatives, the bakau piles or the wooden piles, the precast concrete piles, steel piles, and micro piles, and also the ERP system, we can somehow put some sort of like the 5 for good one, and 1 will be the lesser one. So of course, we need everything goods, but very cheap as well too. So this is how we table it. And if you look at the graphical form, the bakau piles or the wooden pile will look like this, and it's actually very low in cost, but we have a problem with environmental friendly and also availability of material. We look at a precast concrete pile. It has a resistance to load, availability of material. Yes, we have all the concrete, but when we talk about handling and installation, it's actually going down, and it's not also so environmental friendly, and the cost is moderate. If you look at steel piles, the same goes, and of course the cost will be higher than concrete piles. If you look at micro piles, of course the cost will be higher. And if you look at the ERP system, basically we have resistance to load based on the studies. We have the availability of material because it's actually made from recycled material, such as recycled plastic and rice husk, and it's a very easy easy to handle and install, and it's actually environmental friendly, and cost wise it's basically cheaper than, of course it's more expensive than the wooden pile, but it's actually cheaper than the other alternative. So it's actually very close to the ideal value curve. So as a conclusion and recommendation, I would say, based on the findings, the rough foundation is thought to give a practical and cost-effective solution for soft ground condition in coastal areas. And ERP system is a suitable replacement for lightweight foundation, especially for bakau piles. Of course, it promotes a green environment and sustainability of natural resources, and the usage of ERP will benefit both construction industry and environment. With that, thank you very much, Datuk.
Thank you, Engineer Arman, on that presentation. So just to fill in some of the blanks, when we construct coastal structures on soft marine clay, which is on the typical of our mud flats, we are definitely guided by the height of the water level during the spring tide or the high astronomical tide, and also on the hydrodynamics of the area. So if you are facing sea level rise and you need to raise your structure higher in order to prevent the overtopping of your structures and to provide a better coastal protection, you will need stronger foundation. And if you need stronger foundation, you naturally have to add piles to your structure. So that is the conundrum that we face. So if you build bigger structures, you need to put piles in. And in the Malaysian construction context, they would revert to using mangrove piles. So it defeats the purpose of you are trying to protect the mangroves, yet you're still using them for construction. So this is our answer to that problem, by introducing a composite type of pile made from waste material and from waste plastics, and also from waste rice husk, which is normally burnt by the farmers. So we come up with this composite material to design this pile system, and we hope that it will catch on and be used in the construction in the future, because we definitely have to build higher embankments in light of sea level rise, which is forthcoming. So that's essentially how we tie in Engineer Arman's presentation to the first two presentations done by Aslinda and Dr. Lee Hin Lee. And we hope that with those three presentations, the entire landscape of the mangrove forest and mangrove coastline of Malaysia has been properly captured today. So we are now looking at a situation where we already have an erosion problem, but it is expected to be worse in the next few years due to the sea level rise conditions. And earlier, we have published a paper concerning the impacts of sea level rise, as well as erosion and tsunami in the northwest coast of Peninsular Malaysia. And it was published in one of our special publications that was produced by the working group on SDTA. So that's pretty much my summary on the three presentations, and we can now move on to our Q&A. And I think we have about 15 minutes. If Central Office agrees with me, can we have 15 minutes of Q&A?
Yes, go ahead.
Thank you very much. So I will just open the chat box and see what has come in. So we have the first one from, let me see, I think we have, okay, let's go into there and see. Mr. Fazal Rehman Kashif has asked about what about the groundwater table levels and adjacent to sea areas. And for that, I think I can just add on to this. I can just say that now in Malaysia, we do not exploit our groundwater as much as compared to other countries. We are basically relying on surface water, and essentially 90% of it is rivers for our water supply. So in Malaysia, if you say groundwater, only 10% of the country depends on groundwater for water supply. The rest are all relying on surface water. So we have not had much studies in regards to groundwater tables in our coastlines or even in our farm areas. But we do understand and we do know the potential of the groundwater. But it is an area which we have lots of ground to cover in terms of research and exploitation. So we have a huge groundwater reserve we have not yet exploited. And to the second question, mangroves require salt water or river freshwater. Okay, I think I can invite Engineer Aslinda to comment on this one. How about where do mangroves grow?
Mangrove grows, they need salt water intermittently, not all the time. So that's why they are very, their growth is very good in between the mean sea level to mean high water. So, and then the species in the riverine where the tidal fluctuate into the river, so we can see the mangrove grow up until the where the tidal stop, the effect stop. So and then the species differ based on the salinity, where like Nipa will grow where the salt, the salinity is low, and Abyssinia normally grow at the near shore area because they can stand the higher salinity. So in between there will be Rhizophora, Bruguiera, Soneratia, and so on.
So the species, well, depends on the salinity, yeah? And you can see that the root systems of those species differ from one to another depending on where they grow. So the ones that was shown by Engineer Arman earlier are the ones that above the water level, and those are probably the rhizophoras. The Avicennias are usually the colonizing. The first colony will form when there is enough sedimentation. That's where the Avicennia, which is the pioneer species, will grow. The rhizophoras will normally start to grow behind the Avicennia colony. Okay, another question that has come up from the chat box is, let me scroll down. There's a lot of comments, but no questions yet. Thank you for your comments. Everyone seems to enjoy the presentation. Let me see. Okay, I can't find a question yet. Okay, here's one from Pawan. Okay, Pawan, how is the mean sea level rise happening in the blue region? You're referring to the mangrove area that Dr. Lee showed. Is that what you're pointing at?
Yes, Dr.
Okay, Dr. Lee, can you respond?
Which one, Dato'? How the sea level rise happening in the blue region? Is it?
The blue region is the area. I think Pawan is referring to the area where the mangrove.
Yeah, so that yellow region and blue region was mentioned in the presentation. So
Yeah,
in the blue region, the mangrove plants may die, as was mentioned. So due to the rise of this mean sea level.
Okay, mean sea level. Why is it mean sea level is happening? Why is it mean sea level rise is happening? Is it this is a question?
Yeah, you showed the cross-section view of the tidal zone, and you showed that there is a blue region, and that's the region where the mangroves will eventually die off. Yeah.
Oh, it means that the blue region will be all the sea water already because your sea water is higher.
So
Yeah, why is sea level rise happen? Because of our atmosphere. Atmosphere is very hot. Then glacier is our ice cap at the northern and southern pole is melting. Then we're going to have a lot of water. So this blue region will be the one that will have a more permanent sea water already. It means that the mangrove cannot grow up in the one that they have a permanent sea water in that region.
Maybe we can let me see whether I can go and bring up the slide. I think I know which slide Pawan is referring to. Let's see. I'll try to share that slide from my side. Okay. So it's this slide, I think. Is that right, Pawan? You're mentioning this area?
Yeah, this area.
Yeah,
exactly.
So this is the area that's where the mean sea level is expected to go up when sea level rise occurs.
Yeah.
So when that happens, the other tidal heights, the mean high water spring levels high tide will be higher than normal once sea level rise occurs. So within this area, the mangroves will experience more inundation. I mean, it will be underwater during high tides longer, and they will eventually start to die off because the species that normally grows facing the sea are pioneer species, and when they are constantly being inundated for very long, they will start to probably die off. So leaving the species that have these roots that are subaerial, these are the ones that will survive. So as sea level rise goes up, your tide levels go up. And then what happens is there is a squeeze happening around here. And your mangroves, the species that will survive are the ones that can that are in the upper section of the backshore area. So that's essentially what this slide is trying to show. So they will further
Thank you.
migration towards the land.
Thank you, Dr. Kishan.
Okay, we'll go back to the chat box and see if there's any more questions. All right. Yeah. Okay. Here are some of the Q&As that are given. Matthew. Yeah. Is there any direct relation to area or width across the sea waves of mangrove protection and the loss of energy of waves of the sea? Can we answer that, Dr. Lee?
Which one? Dr. Isham?
No, there is a Q&A. There is a Q&A.
Yeah. Wonderful. Good. Use. Where is it? Which physical structures you presented in a more economical? Is it and they're long lasting for the protective? Is it this one? This question?
No, I'm going to the Q&A box, so you can see that. Can you see Q&A? Can I?
Yeah.
Okay, that's somebody. Litty Matthew asked the question: is there a direct relation to area or width across the sea waves of mangrove protection and the loss of energy of waves of the sea? I think the answer is yes. I mean, if there's a high energy due to waves and currents, the mortality or the survival rate of mangroves are going to be decreased. So the mangroves, typically, if you replant mangroves, their chances of survival is higher if they are in calmer areas. So that's pretty much the answer to that question. But Dr. Lee, can you elaborate on how the nearshore breakwaters that we have built help the mangroves, help the replanting of mangroves again? I mean, you presented it just now, but can you just go over it again?
Okay, but I don't know which question is they're asking, but based on that question, so actually when we have a structures at the nearshore area, of course, when we have either they are in the hard structures or they are in the soft type of the method, both actually they will dissipate the energy. Once, for example, Dato', if you look at this slide, the one that they built the geotube at the offshore, when they build the geotube at the offshore, because this area is in the beginning is eroded shoreline, because they have receiving a higher current speed and the higher wave height. This is why we can see that at the back of the shoreline here, they are more being erosions happen there. But near to this area, they have a chalet area. Back to previous slide.
This one, is it?
Yeah, this one. You see the number 3 one. No. Yeah, this one.
Yeah.
So we have our geotube, and before this geotube, actually the shoreline is having being eroded already. That's why they are putting in the geotube. Once they have the geotube, actually they have reduced the energy, either the current energy or the wave energy. Because of the energy has been reduced, so at between the geotube and the shoreline, the soil have been piled up already because you have lesser energy. Then more eddy happen at that side, and the sediment is start to settle down. Once they settle down the sediment, then we can do the replanting already. That is a concept. Why is it we need the structures? If without the structures, the shoreline will be still erosion happen.
Okay. Thank you, Dr. Lee. I hope that answers it. The presence of this structure basically is to dissipate energy and create a calm. So when you create a calm behind the structure, So there is no direct waves coming in, but you have waves that are probably just with energies reduced. So when you create a calm, the chances of sedimentation will be better, and the chances of growing new saplings of mangroves will be better, and you'll get greater survival rates. Right.
That's why the slide, the one that at the bottom, you can see the mangrove is start going out already.
Yeah, this is the area here over time.
Yeah.
Okay, thank you, Dr. Lee. And we'll go back to the Q&A box and see what else is in here. How can we conserve our mangrove forests? Maybe we can let Arman answer this. He has worked with coastal structures in mangrove areas. Arman, can you add your ideas to this?
Yeah. Hello?
You check your mic. Are you muted?
Dr. Kau want to say something?
Yes.
Professor Kao,
Yes.
would you like to join the discussion?
Yeah, it's very interesting topics. I'm interested about using the geotube before the mangrove grew up. So in order to reduce the energy of wave and the current. So how about the geotube, the material? And it is easy to maintain us, or in my experience in Taiwan, we use the geotube. It's easier to broken because either the material is not so easy to maintain us. Do you have this situation in Malaysia?
Yes, this I like to invite Engineer Arman to comment. He's familiar with this kind of structures. Arman, can you unmute your mic? Hello, are you still there?
I think he's not connected right now.
It's not connected. You left. Trying to see whether it's still.
Yes, I can't unmute.
Oh, okay. It's gone red. Both mic and
yeah. I think it's a problem from his end.
Okay. Anyway, I think I can help Professor Kao on this one. Yes, we do have issues with geotextile tubes, but the first issue is with fishermen. They like to put their fishing rods inside this. They like to puncture through the tube and put their fishing rods. So they are the major cause of damage. And once you have a tear in the geotextile tube, it's very difficult to contain it. So you've got to come in and patch it up. So that has been an issue, I think, with almost all our efforts. So we have since moved on from geotextile tubes to other forms of protection. And we are looking at building low coastal structures, and we also have built proper breakwaters to protect, especially in the area of Tanjung Piai that was shown earlier, in this area here, in the southernmost coastline of Malaysia. I don't know whether there's a slide in this presentation. I think there was one earlier. And
at the last one.
The last one.
Second last.
Second last slide.
Okay,
let me see whether I can get there. Yeah, this area, right?
No, one more. Yeah. This one. Previous one, Dato. Yeah, this one.
This one, yeah.
This is Tanjung Piai.
So we have built breakwaters now, proper rock breakwaters to protect the area. This latest settlement in Tanjung Piai, Johor, it's just across the Straits of Johor from Singapore. And this is essentially the southernmost tip of the Asian continent. So we are losing that southernmost tip slowly because of erosion. Okay, I'd like to go back to the Q&A box and see, okay, how do we conserve mangrove forests? And number one is we have to really protect them in the sense that we have to control the harvesting. So not much what you call timber is being produced nowadays from the mangrove forest. We have realized the importance of it, and most of the states in Malaysia have gazetted mangrove forests as permanent reserves. So that's the answer. And the next question is from Madan Mohan, and it says here that salinity is one of the crucial factors of mangroves may vary based on certain range, species, and he asks, are you done any study for different species while going for plantation? Aslinda, I think you were involved in the mangrove replanting task force. Can you answer this?
Thank you, Atul. I'm not a biologist, so this is not my expert area, but according to the interactions between the biologists in Forestry Research Institute of Malaysia, they already have some studies on what is the salinity according to the zonation of mangrove species. What Nahrim do is we take salinity normally in the offshore side is about 32 ppt, and in the area further inland it will grow lesser, like 20 and so on, until in the river there will be like very low salinity. So but personally in Nahrim we have not studied the species according to salinity.
Okay, thank you. Next question from Muhammad Osman from Somalia, and he asks, we would like to ask on the impact of climate change on mangrove population in Malaysia. I think Aslinda, you studied this.
Okay. What we impact of climate change, we have not. I mean, sea level rise is also impact from climate change. So we normally because previously we have the projection of sea level rise along the coast. So now from that value, we will go to mangrove area and study how much the inundation will happen in the future within like after 20 years, 40 years. So that's why so in this case for Port Kelang, we can see that the inundated area is getting bigger. So the green one is mangrove, and the blue one is the water inundation. So if you see the sea level rise of 2.2 meter, so a lot of the mangrove has been covered by the water. So this may the plants may die off after a few I mean after a long time of inundation. So
yeah, thank you, Aslinda. So to that for that question, if I can add, the global projection for Malaysia is a sea level rise of 0.73 meters over the next decades until 2100. So if you prorate that, you will get an 8 to 16 millimeters per year if you based on the low to the high projection of 0.5 to 0.98, and the same on average is about 0.73. So that is how high the tide is expected to rise in the future. So of course, with the rising of the tide, you get more areas inundated, and flat coastlines are the ones that will we're seeing the intrusion of the sea level to the sea level inland. So that's our greatest fear. So if you can imagine countries like Maldives, where when you have a sea level rise, and their highest peak is probably about maybe 3 meters or something more than close to 5 meters. So the amount of land that will be lost due to sea level rise will have a serious impact on the economies of the future. So here's I'm bringing up some pictures to illustrate. So this is the southernmost tip of the Asian continent, like I said earlier, in Johor. Singapore is just a bit more to the across these straits. And we have marked this shoreline change, and these are all very flat shorelines. And you have a steady loss of mangroves along here, and this is how we see from an aerial view of the coastline. So gradually, these lands here will be further eroded, and this is an area which is undeveloped. So undeveloped lands are, of course, not our focus when we want to put in coastal protection, but in most areas of Malaysia, you have immediately after the shore, you have aquaculture, and sometimes further in a bit you'll have settlements, and even further up there is actually planted paddy. Yeah, so these are the impacts of the various human activities that we are already seeing. And when sea level rise actually happens, we are going to see accelerated degradation. So that's the situation that we are facing, and I bet it's happening everywhere. So I hope that answers Muhammad Osman's question. And next question is from Ashok Srimali, and he asks if there any local movement to save coastal forests. And the community response, oh yes, we have. Fortunately, in Malaysia, we have more. We have a lot of the private sector joining us, and here's a picture of it. I can get this. Yeah, they have schools. We have programs for schools, for university students as well. The NGOs have come in, and even fishing communities have also contributed. Fishermen's associations. Basically, when it comes to mangrove replanting, we have actually the whole spectrum of society coming into the activities that we are organizing. So we have no problems with that. So as you can see in these pictures, these are all community-based programs, and led by the forestry department and supported by research agencies as well, like us, National Hydraulics, National Water Research Institute. So these are some of the images, and I can move on to the next question. Mr. Yelameli, how groundwater is contributing to mangrove ecosystem with respect to quantity and quality? Well, like I said earlier, we have not really looked at how much groundwater affects the mangrove ecosystem, because we are basically focusing on a lot of surface water. And the biggest problems in Malaysia is surface water, too much of it. We're getting 2,800 millimeters a year. And despite all that, we do have periods of scarcity, especially in major cities, due to pollution, basically due to pollution. But we have plenty of surface water, and then and a huge storage of groundwater, which we have hardly exploited. So, okay, I would like to invite the speakers to go to provide some of additional comments before we close the session. It's now 7:41 p.m. in Kuala Lumpur, and I believe it's about 5:11 in New Delhi. So if I can now invite Engineer Arman to make some comments on whether to add on to your presentation or to provide some insights, further insights, please. Or is he around? He's not around yet. Still not around.
I think Arman have problem for he cannot. He return here. He cannot. I cannot unmute my mic.
Oh, okay.
So sorry.
So, all right. So Arman's presentation was basically the most engineering of the three. and it reflects on the reconstruction practices in Malaysia, and how the next challenge that we're going to face is how do we build bigger or higher coastal embankments to prevent inundation of our coastal areas. So that's how that'll be the challenge that we'll be facing in the future with sea level rise and the increase happening of storm surge and what you call wave erosion on the coastline. So then next, I would like to invite Dr. Lee, if you want to add on to your comments earlier, please.
So far, no comment, Dato'. Thank you very much.
Everything.
I hope the information that I share can be useful to everybody. Thank you. Thank you.
Okay. Aslinda, you're next.
Okay. I didn't mention before, but due to sea level rise, some researchers in the world have studied that the mangrove can encourage sedimentation. So they said that because they can migrate landward, there shouldn't be any problem to the mangrove. But in Malaysia, because at the back of the mangrove area, they already have earth bunds, which will stop the migration of mangrove landward. So in the end, finally, the mangrove will get the thinner and thinner, and maybe no more mangrove in front of the earth bund.
Yeah,
And also, yeah.
That phenomenon is called the coastal squeeze. The mangroves will be squeezed between the rising tide and the coastal embankments that are behind them. Right. Thank you, Aslinda, for your comments. Professor Kao, as chair of the working group on SDTA, any comments, sir?
Yes, I think the key problem is the coastal erosion. The coastal erosion, of course, for the presentation, almost is focused on the sea level rise, because the sea level rise makes your shallow water coastal area, while we make the water depth is more deep, so the wave energy are more stronger. So it's the erosion's ability will be more serious. So I have a comment: soft and hard protection is needed to reduce energy. So not only for the mangrove, before the mangrove grew up, I think the smallest the coastal engineer protection is needed. And the other point is the because try to find the reason of the coastal erosion just only or the sea level rise. But I watching the presentation, I found since 2017, the sea level rise, you have the sea level rise data. But for your record the before the 2017, since to 1985, your discovery the coastal erosion is very serious. So before this observation data, I have the suggestion we can re-evaluate and re-evaluate and can be try to find the real real problem to diagnosis to find the method to protect it. So it's my comment. Of course, after then the pandemics, I sincerely invited your lab to my lab, can cooperate more exchange the experience. Okay.
Thank you very much, Professor Kao, on that invitation. Essentially, yes, I definitely agree with Professor Kao's observation. The coastal areas will be the areas that will be immediately threatened. I think in not only from sea level rise, but with most of our our paddy areas very close to the coastline, we will be facing other challenges as well, especially when you have a storm rainfall, high rainfall in the hinterland, and when it coincides with a high tide in the sea. And that is the worst case scenario that we are facing in Malaysia now. And that has put a lot of pressure on our government to build proper flood mitigation systems. I guess that's all that for this webinar. And Professor Kao?
Yes, sorry.
Yeah.
I have an interesting question. As you know, the Malaysia is near without, it seems not the typhoon path through, right? Not typhoon path through.
No.
But how about the wave source? Wave source from far field to the Malaysia? Where? How to generate the wave?
Oh, for the west coast, we are pretty much protected by Sumatra, so the fetch is very small. But on the east coast, we do have severe monsoon storms, and because the fetch length extends all the way to probably to China, so it's about over 1,000 kilometers. So that's our biggest threat from waves. It's from the South China Sea, and but not so much on the east of Peninsular Malaysia. Sorry, on the west of Peninsular Malaysia, which is protected by Sumatra. So we do not face the Indian Ocean. We face the Straits of Malacca.
Okay, so you mean it's the long period wavelengths and the swell from far? Yeah, okay, I see.
It's from the South China Sea.
I think the long period wave, the energy is stronger than the monsoon wave. Yes, I see.
Right.
Yeah.
Right.
Right.
So that's why we don't have many mangrove forests on the east coast of Malaysia. So I think we have to conclude. It's almost 7:50 in Kuala Lumpur, and I wanted to finish this before under 2 hours. So I hope we have 10 minutes. So I think that's all for this webinar. I thank everyone for participating. I thank the 3 speakers who have contributed their presentations. And I think all these presentations will be uploaded into the Working Group SDTA's website and made available to members. Is that all right, speakers? I think Aslinda should be okay, yeah? All right. So with that, I thank everyone, and I hand it over back to Central Office.
So we are thankful to the SDTA work group for a very good contribution to the knowledge, and we expect more in future also. Thank you, everyone.
Thank you very much.
Great.
And
makes sense.
Bye.
Bye.
Take care.
Thank you, Dr.
Thank you,
Hisham.
speakers. Thank you.
Very nice session.
Thank you.
Goodbye.
Bye.